So we're going to start with your notes. You should have a note packet, and up at the top it says Age of Earth according to scientists. And so we know the Earth is really, really old, and but the thing is you need to know the exact number that scientists say for this particular topic. And so they say that the Earth is 4.6 billion years old, and at the top of your notes you'll see it says Age of Earth according to scientists, and then there's a blank underneath it. You're going to write this number on that blank. And again, feel free to pause the video or rewind if I am going too quickly. You can pause it, write what you need to, and then play and continue. So, a lot of people say, what? How could they possibly come up with that, you ask, that number? Well, there's going to be three things that we're going to talk about, what makes scientists think the Earth is actually that old. And if you look on your note packet, right underneath where you just wrote, it says, what makes scientists think the Earth is that old? And there's those three basically kind of stars, call-outs for you to put your answer. And so one of the things that we're going to study is the fossil record. So you can put that on your paper in one of those spots. Another one is radiometric dating. And this one can be pretty complicated. However, they want us to just kind of know the gist of it and what it is. And then the last one is stratigraphic superposition, or the law of superposition. And that sounds pretty complicated, but this one is actually pretty easy and fun to figure out. And we'll talk about that one in a little bit. So each one of these, we are going to go into some detail. But I would recommend taking some time and just on this front page of your notes of what you filled in so far, making sure you can rattle these things off. How old the Earth is, what makes scientists think the Earth is that old, and list these three things off. So we're going to start on the next page of your notes with the fossil record. And we should begin with some important words that you should know. And I don't want to presume that everyone knows them, but fossil and paleontologist. And so a fossil is the preserved remains or traces of living things. And a paleontologist is a scientist who studies the fossils. And of course, when I think of a paleontologist, I can't help but think of the famous movie of Jurassic Park. And the scene of the movie where the two paleontologists who happened to be paleontologists who specifically studied dinosaurs got to see a real dinosaur moving around. And then, of course, that later turned into a nightmare, right, when we had that scene of the movie. But for fossilization, how can something become a fossil? And I wanted to give you these visuals of that. And so here we believe that dinosaurs roamed the Earth about 65 million years ago. Then they had to die. And scientists rely on these preserved remains to learn more about dinosaurs. And after an organism dies, its body is exposed to a lot of things: scavengers, decomposers, wind, rain. They can, if they're quickly buried, like a flood or a mudslide, they can be preserved. And then they get covered with sediments, and you can see here we have lots of sediments, and it's even covered with more sediments. Here's our fossil down here. Going back to that idea of the law of superposition, the law of superposition says if you have this many rock layers and they're undisturbed, you should be able to find the oldest on the bottom and the youngest up at the very top. Now here you can see though that geologic processes, there's been an earthquake, there's been faulting, have caused the uplift. And buried rocks can end up, and buried layers can end up at the surface. Weathering and erosion can wear them away. I do want to point out, just for future reference, that I'm sure your eyes were drawn to this spot right here. That is a fault. That is a break in a rock, and you can see that the rocks have moved on either side of the fault. And the layers themselves, since they don't line up, really help indicate that there's a fault there. And I can also tell that the fault is younger than these other rock layers, that these other rock layers were already there and then the fault happened. So uplift, weathering, and erosion, and then they're exposed at the surface where people can investigate them. We also have this one, just for a visual, how fossilization happens. We've got to have something laying at the surface. A lot of times, scavengers like this bear here, or predator I should say, like this bear, will remove the softer tissues of the organism. You can see some hyenas there in the front of the screen. This one's a little graphic, I guess, But anyway, so the bear will remove some of the soft tissues. The hyenas will come in and remove some of the soft tissues. Afterwards, other scavengers will come in and remove some of the remaining soft tissue. And then these remains would need to be preserved and fossilized. And that would happen most likely if the animal is buried quickly. Things that can do that are flood, sandstorm, collapsed burrow, mudslide, volcanic eruption. The remains can get covered in ash very quickly and be preserved that way. They might be buried under sediment when animals trample on them. If it's buried within 5 years, that means it has the best chance of being a fossil eventually. So in this particular one, you can see years up here at the top. We're going through a 5-year time period. And over these 5 years, these bones are going to be fossilized and preserved. We'll have a windstorm come in and move some sediments over that. Lots of wind. You can see that this is happening over 1. Now we're up to 2 years. We have a flood that happened in year 3. And these remains are completely covered. Now here's some other things about fossilization that occurs. You may know some of this in more detail, but some minerals come in and replace some things inside of the bone. And then over time, again, here we have this where it has to be buried. And it's being buried with sediments. And you can see the more layers on top, this kind of shows that it's getting warmer. This is a lot of pressure pressing down on here. If you've ever been to the beach and just been covered under a year of sand, you can see here we're at the 5,000 year mark at this point, how heavy that is. So this is a lot of pressure, and it causes fossilization, and this is buried in a sedimentary rock. Because remember, sedimentary rocks are when sediments get pushed together and become a rock. Here's just some more processes in the fossilization. And then remember, activity, weathering and erosion can bring these things to the surface. People usually find these fossils when we're mining or maybe we're excavating so that we can build something. But when they find these things, you can see that they stop and they call in someone who's a specialist to continue undigging the fossil using much more delicate tools than what they were using in the past. So those are just some of the ways the fossilization occurs and how those can end up at the surface. So next, the fossil record. So all these records of fossils and all the layers of rock provide evidence of 3 things: the history of life on Earth, past environments on Earth, and it shows how different groups of organisms have changed. And so there's a place in your notes for these 3 things. But essentially, all 3 of these things are showing that the fossil record shows changes over time. So in your notes, there's that. In summary, it shows changes over time. Again, feel free to rewind this at any points if there were any notes that you did not get. But this is the notes that we took in class today.